Assalamualaikum. We are from Group 8 and the task given to us is that we are required to design wireless communication project by using simulation in MATLAB software. Type of simulation technique that we are using are offset quadrature phase shifting, Oqpsk. For the introduction, offset QPSK is a variant of phase shifting modulation using 4 different values of the phase to transmit. It is sometimes called staggered quadrature phase shifting as QPSK. Oqpsk limits the phase jump that occur at symbol boundaries to no more than 90 degrees and reduces the effect on the amplitude of the signal due to any low pass filtering. A modified form of QPSK where the bit waveforms on the I and Q channels are offset or shifted in phase from each other by 1/2 of the bit time. Because changes in the I channel occur at the midpoints of the Q channel bits and vice versa, there is never more than a single bit change in the D-bit code, and therefore there is never more than a 90-degree shift in the output phase. In conventional QPSK, a change in the input D-bit from 00 to 11 or 01 to 10 causes a corresponding 180-degree shift in the output phase. Therefore, an advantage of Oqpsk is the limited phase shift that must be imparted during modulation, and the disadvantage of Oqpsk is that changes in the output phase occur at twice the data rate in either the I or Q channel. This is the block diagram of Oqpsk.
So for the simulation part, first of all, we go to the random integer generator block used to produce random binary or integer data. For this integer block, we set size equal to 4 in order to create 2 bits. Next, this is Oqpsk modulator baseband block used to modulate the input signal by converting the input bit stream for the suitable transmission. Next, we go to complex to real imaginary block where the real outputs are the same data to the complex input from Oqpsk modulator in the complex to real imaginary. Okay, next is a sine wave generator block that was used to construct the multi-channel imaginary Oqpsk signal. We set the amplitude equal to 1 and frequency equal to 4 multiplied by 5 and the sample time is equal to 0.001. Next, we go to the cosine wave generator block and it is used to construct the multi-channel real Oqpsk signal. The parameters used is the same as to the sine wave generator except for the value of phase is equal to pi divided by 2. Next, we go to the product block where it is used to return the result of multiplying two inputs, which in our case, it is used to multiply the output of sine wave and sine wave imaginary and cosine wave real signals. Next, this is addition or sum block used to add or remove input that are scalar, vector or matrix. It can also execute a summation and collect the pieces of signal. This is additive white Gaussian noise, also known as AWGN channel. It's a simple noise model used in information theory to imitate the effect of numerous random events that occur in nature. And this is the Oqpsk demodulator. Is a reverse version for the operation of Oqpsk demodulator by recovering the original signal from the Oqpsk modulator signal. Next, we go to the Constellation Diagram that was used to display real and complex value floating and fixed point signal. And lastly, the scope, or also known as scope viewer, is used to display the time domain signal. Next, we go to the result. This is the Oqpsk modulated signal. As we all can see, where the Q channel or sine channel shows the delay by T divided by 2 or half of a sine. And this is the result for Oqpsk demodulated signal. Where if you compare to the input binary random signal, the Oqpsk demodulated signal was 1 bit or half a symbol delay. Next, we go to the Constellation Diagram. when we set for the signal to noise ratio or SNR ratio equal to 10 dB. Next, we change the value of signal to noise ratio equal to 40 dB. And lastly, we increase the signal to 80 dB. And the result for SNR ratio equal to 80 dB shows like this. From observation, we can see that the Constellation diagram of before and after show that the distortion of signal is plainly visible when SNR ratio in dB drops.
So now we discuss about the result that we have achieved just now, and this method is using the maximum phase shift that is about plus minus 90 degree, and the signal does not cross zero, and for the time cycle is at 1/4 as shown in the constellation diagram, and the Oqpsk has been compared to the QPSK has been compared to the Oqpsk. The constellation diagram is one of the ways to show the modulated signal scheme like the QAM, for example. And then this method, QPSK method, the disadvantage is it will produce a distorted result at the waveform transition. So to eliminate the distortion, we are using the Oqpsk to reduce the distortion in the end of the result. And the data from the signal has been delayed in the quadrature component by t over 2 seconds. And as you can see, like the result, the AWGN has been used to add the noise from the modulated Oqpsk signal to get the distortion at first, but to eliminate the distortion we have to increase the SNR value. And for example, like the result just now, the more the value of the SNR has been set, the less distortion it gets at the end of the result. Okay. In conclusion, Oqpsk can be designed using the MATLAB Simulink, and we can design it with ease, and we can understand all the block diagram in the library included inside the MATLAB Simulink. And as the block diagram shows, the project begins with the random integer, and it acts as an input for the modulator block and will pass through the AWGN channel, and the process inside the AWGN channel will add some noise to the original signal, and then will send as an output to the Oqpsk demodulator to recover the original information from the original signal. And then to display the distortion from the signal, we use the constellation diagram that can be found in the Simulink library, and we can observe the exact location for real and complex value on the IQ plane. So the advantage is that the I and Q bits in the Oqpsk are half a symbol period apart. This is to limit the maximum phase change to 90 degrees and eliminates any spurious high frequency components. And lastly, Oqpsk has an disadvantage of introducing a half symbol delay into the demodulation operation. And that's it from us.